Hey guys, so this is actually our last day of the chapter 6, day 5. We're going to be talking about parts of similar triangles. So, I wasn't playing whenever I said similarity was going to be the key to this chapter. And so today we're going to identify similar figures and use ratios proportions to solve mathematical and real world problems. So, in other words, we're going to be doing a lot of cross multiplying today, setting up two fractions equal to each other and cross multiplying. But real quick, it is Friday. Let's do a quick flashback Friday. We got a problem from yesterday, guys. We want to find A. This involves yesterday's theorem, the triangle proportional segment theorem. And I want to give you guys a chance. See if you can try this first problem for me, please. Let's see if you guys can find A. For those of you that are cheating right now and did not pause the video, all I've done is set up the proportion. A and 20 are proportional, and 9 and 15 are proportional because of these three parallel lines here. So pause the video now and see if you can solve for those of you who cheated. All right, so we cross multiply. 15a equals 20 times 9, that's 180. Divide by 15. We get A is 12. And so that's a little throwback to yesterday. Today's honestly mostly going to revolve around this theorem right here. This is going to be the big theorem for today. If I could pick just one, this is going to be kind of the main key theorem, the proportional perimeters theorem, which shows that, hey, if you have two triangles that are similar, then the perimeters are proportional to the measures of the corresponding sides. So in other words, we can set up a fraction or fractions, one involving perimeters. So we can use this to help find perimeters of triangles that we maybe don't know. So check it out. Check out this big triangle here. We've got this triangle where all we know is one side. How on earth could you find the perimeter of this thing if you only know one side? Well, that side is going to be similar to this because we are told these triangles are similar. We're told that. And here's the thing. Can we find the perimeter of this triangle? Yes, we can. 14 plus 9 plus 12. That's going to give us a perimeter all the way around of 35. Okay. Here's where we can set up proportions using perimeters. So here's the thing. Let's call the perimeter of this, let's call it P. We don't know it. So we can take 35, the perimeter of this big triangle, and make it proportional to P, the perimeter we don't know. And then, of course, that can be corresponding to the measures of corresponding sides. So 12 over 5. And you can actually solve for the perimeter for a triangle that we only know one side of. So cross multiply, divide by 12. Perimeter is going to be, remember, perimeter's got to be in units, of course. Perimeter is going to be 14.6 units. So that's kind of wild. You can find the perimeter without even knowing all sides of a triangle. That's pretty convenient. Something a little bit smaller as far as that's going to be used today, but still important. Let me adjust my camera. It deals with altitudes. So if two triangles are similar, once again, then the measures of their corresponding altitudes, we know altitudes are the vertical heights, are proportional to, once again, the measures of the corresponding sides. We see this language in both of these. Perimeters are proportional to the measures of the corresponding sides, and altitudes are proportional to the measures of the corresponding sides. So in other words, that right there. Sides are proportional, altitudes are proportional if the triangles are similar. And I'm going to let you guys try this. Let's see if you can put this into action here with this last problem on the page. The triangles below are similar. We've got segments marked as being 3 and 5 units long. Those are our altitudes. Find x. So I'm going to let you guys try. You can pause the video and try this problem. See if you can find x, the missing side. All right, so we see the altitudes are going to be proportional and the sides are going to be proportional. So I even labeled these fractions. Here's our altitude fraction. I went big to small, which means I also have to go big to small. Cross multiply. This math is going to be a heck of a lot easier than some of the past ones, although we do end up getting a fraction. The side length is going to be 20 over 3. You can't turn that into a decimal because it is an irrational number. It's an infinite decimal. Okay, so that's our first page. Let's head on over to page 2, guys. Now you guys are going to see a lot of repetition here. Check it out. So on the previous page, it was corresponding altitudes match up proportionally to corresponding sides. This time, angle bisectors are proportional based off the measures of sides. And once again, the whole point is this works if we have similar triangles. Great circle by me there. Fantastic circling. So again, same thing as altitudes. Boom, boom. You could say the same thing for corresponding sides. So not too much to talk about there. That is true if, once again, we have angle bisector. Oops, sorry, didn't mean to make that 2. 1 and 1, 2 and 2. And let's see how that works below here. So the triangles are similar. The segments labeled 3 and 8 are angle bisectors. So those angles are the same. These angles are the same. That means, of course, that the line that is a bisector, those bisectors are going to be proportional, as are the sides. So you've got x over 5, and that's our sides, proportional to 8 over 3. You guys know the drill. It's always cross multiplying to solve when you have an equation you're solving for x. And when we divide, we end up getting, you definitely want to leave this as 40 over 3. We get another irrational answer there. Now be careful, guys. Be careful on number 2. This one's a little bit tricky. So once again, we have an angle bisector. We see that these 2 angles are the same. But the thing is, this time we don't have the bisector. We have sides that are split by that bisector. So this goes back to yesterday's. This is more of a yesterday problem. Remember from yesterday. If you have a situation like this, we know then that these sides are going to line up in a little bit of a different way. So 9 and 21 are going to be proportional, side and side. And then x and 14 are going to line up. And of course, we know 9 and x on opposite sides here, they have the same angles, so they're actually going to be the same side. So we're going to have 9. And then on the top of this fraction over here will be x. And then 9, of course, goes with its proportional side, 21, as x goes with its proportional side, 14. So you cross multiply, divide, x equals 6. Hopefully you guys are feeling pretty good about that. If not, you know how to get in contact with me. But let's finish up page 2 strong here, guys. We'll try and get this video in just around 11 minutes. That way this first video, part 1, is not too long. I know you guys like those short, snappy videos. Try to give those to you. So once again, I'm not playing. If 2 triangles are similar, corresponding medians are proportional, of course, based off the measures of the corresponding sides. All repetition. You guys are seeing how it's kind of going here. So we can say, of course, these sides or these sides, depending on, what we're given. This is the connection we have here. So corresponding medians are proportional, corresponding sides are proportional. Okay, and let's see how that works right here. So we know that we're going to have x plus 1 this side. And of course, this is we're assuming a median, splits these two in the middle. It's going to line up with this side. And then 16 is going to line up with 28. So you guys know the drill. X plus 1 is going to line up with its proportional side, equal to 16. I don't usually do the smaller shape. I apologize for that. Over 28, not that it's going to matter. And I'm going to let you guys see if you can finish this problem for me, please. See what you guys can do here now that we've set up these proportions based off corresponding proportional sides. Solve for x. Make sure you realize we're going to need to distribute 16 to that and 28 to that. Okay, so I end up getting 28x plus 28 equals 32x minus 32. I would subtract 28x over to get 4x, which means you want to add 32 over to get 60. And 60 divided by 4 gives you 15. All right, and that's the end of part 1, guys.